and welcome to the video demonstration of Semi-Automatic Electrical Machine Laboratory Open Lab. This is a very state-of-art machine lab learning equipment where the student can make their own motors depending on their requirements. So for that, this is a complete unit, and as we can see here, there are three types of stator. First one, this is the stator, which is having the AC windings on the stator. This is DC stator, having two poles. You can see two poles here, and these are two interpoles. All the windings are brought up on this terminal plate. All the windings are brought up on this terminal plate. Like also for AC stator, the windings are terminated on this terminal plate. Likewise, this is the rotor for permanent magnet machines, the stator for permanent magnet machines. So we can see there are two poles, magnetic poles. Now, these are three types of rotors available. First is the DC rotor, which is having the commutator. Second is the squirrel cage rotor, and third is the wound rotor or the rotor with slip rings. These machines can be built up into several machines. These units can be built up into several machines. So this is the base plate with these type of bearing holders. These are bearing housings in which the motor shaft will move, and we are provided also brush holders. This is the brush holder for DC machines. See, these are the brushes, and this is the brush holder for slip ring machines. This is the brush holder for slip ring machines. Here, this is the electromagnetic load unit. And a load sensor is implied over here through these two screws. This load sensor will transduce the mechanical quantity to the electrical quantity to be displayed on the meters. So these are the mechanical parts of this electrical rotating machine. Now I will show you the different units provided for operation of this machine. The machines is to be coupled using this type of coupler, and the black portion we are seeing here, this is the optical sensor which is mounted on this bearing housing. So the entire machine would look like this. So we can see here, this is the stator for AC, this is the rotor for slip rings, this is the coupler, this is optical sensor over here. Here is your stator for DC and rotor for DC. So after combining all the units, this will look like this machine. Now for the successful operation of this machine, we are providing this electrical power supply. Now this electrical power supply is having four outputs, namely A, B, C, D. So I will show you how this will work. this unit, for starting this unit, we have to pull up this MCB and push this black button for start. Now you will see this unit has started. You can get it from this LED glowing. Okay, so now if I want to select A, I selected parameter A. So here at A, the output will be 32 volt DC. If we have selected A, then the output over here will be 32 volt AC, and the current 32 volt DC over here, as A is selected, 32 volt DC with 14 amperes rating. So output here will be 32 volts, 14 amperes, and 24 volt AC with 14 amperes. That is, here line to line voltage will be 24 volts. Now if I select B, here the output voltage at DC will be 42 volts, 10 ampere, and the output voltage at AC side, will be 42 volts face to face with 10 amperes out current. Again, here if I select C, then I would get 0 to 40 volt 5 ampere DC variable over here by moving this knob, and at the same time I would get 0 to 48 volt AC 5 amperes single phase at these two terminals. If I select D, then I would get 0 to 8 volts 12 amperes DC at these two terminals, and 0 to 10 volts 12 amperes at these two terminals by moving this potentiometer. So this is how the 4 power supplies are selected. Above that, there is a box naming loads and rheostats. So here we are having resistive load, capacitive load, and rheostats over here in form of potentiometers. You can see here. So this is 80 ohms, this is 2 ohms and 1 ohms. This is actually 1 ohms plus variable 2 ohms. So these are the load modules, and here in this box, this is the starting and synchronizing unit. For rotor resistance starting, we will use this knob for rotor resistance starting, and if we want to work as a synchronous machine, then we will put this knob at these terminals, these outputs, and this will provide a variable DC voltage over here of 20 volts. Moving further, when we want the parallel operation of alternator with AC main supply provided from the electrical supply box, then we will use this parallel board. It will use the dark and bright lamp method. Again, here this will be the electrical measuring module. The meters over here can measure AC and DC both parameters. The AC and DC can be selected using this function press switch. Here we have to connect, if we have to connect voltmeter, we will connect here, and for ammeters we will connect here. This unit is mechanical measurement unit. So what type of mechanical measurements we can take here is torque. We can take torque, we can take speed of the motor, and we can take the temperature of the motor in this panel. Beyond that, this is a pole changing unit. Pole changing unit is used to make a motor, Dylander motor, where the poles are changes from 2 to 4 using this pole changing unit. So in Dylander motor, which runs in 2 speeds, where at one speed it is 2 pole, at other speed it is 4 pole. That Dylander motor can be made using this pole changing unit. And one more, star delta starter. If we want to run a motor using star delta starter, so this would be the star delta starter. The induction machines would start and run, and then for the load calculations we will put it onto the delta mode. This unit is provided with this acrylic cover. This is a safety cover. After making the connections and before running, this acrylic cover is to be placed so that the student does not directly can touch the moving part of the machine. So this acrylic cover is also given. The screws for this acrylic cover, these are the screws for this acrylic cover. This is the accessory box which we have provided with both the machines. As we can see here, the accessory box for another machine is over here. So this is the accessory box where we have provided 2 Allen screw drivers, Allen key number 1, Allen key number 2, Allen key number 3, star coupler with Allen screws, assorted Allen screws, five books of manuals, volume 3, panels, appendix, volume 1 and volume 2. Beside that, these are 2 units for USB to RS485 converter. These are 2 USB to RS485 converters, 2 units. This is reflective strips, 3 numbers each set we have given, and a magnetic probe. 2 numbers of magnetic probe are given, 1 for each set. This is also 3 numbers of strips are given, so there are total 6 strips, 2 sets of this. Besides that, RS232 male to female converter, 2 numbers for 1 unit. Other unit is also having 2 numbers of RS232 converter. These are pen drives for the software. This is the adapter bracket. When we will mount the electromagnetic brakes, the adapter bracket will be required. This is locking and rotating unit. Assorted patch codes. This small patch code, 15 numbers, blue color, 20 numbers assorted medium length patch codes, 6 number of patch codes red and black, and very big patch codes, 15 numbers, long patch codes. three types of round pin cable, 1, 2 in 3 for various operations. One more set of Allen key, Allen screws. This is balancing arm, which is having a graduated scale over here. One can see the scale over here, and this is the arm with the spirit level, and these are weights. So these are the accessories which we have provided for both the units. One set is over here and the other set is on the another table. Load cell is also there inside this box. Load cell is there for this unit. This is the load cell. For other unit, the load cell is itself planted on the electromagnetic brake. Here we are going to start our first experiment, flux produced by the poles. For that we will require direct current stator. This is the direct current stator. You can see here, this is a stator for DC machine. Magnetic probe, this is the magnetic probe. 10281 power supply, this is 10281 power supply. Electrical measurement module. So this is the electrical measurement module. So for first application we want these 4 items. Now we have to connect as shown in the figure. Over here also, as shown in the figure in the manual, we have to connect the circuit diagram. Now as per the diagram, we have 0 to 8 volt supply is used. So I would use the option D over here, and as it is DC supply, so from L plus and L minus I will get the supply 0 to 8 volts to the unit, and here I will place a probe inside this using this hand, and one can see how the magnet behaves. And using this function button, one can have voltage, current. Using this function button we can change to DC values, voltage, current and power. Okay, now increase the voltage and put the voltage this magnetic probe inside this unit. As you can see, this magnetic probe, it aligns with the magnetic poles as soon as I insert this magnetic probe inside. Okay, now if I decrease it to up to 0, the magnetic poles are not aligned with the magnetic field. So one can see how the magnetic field is generated inside the stator of DC machine. For the next experiment, how the main magnetic field of DC machine is generated. So we have to connect the circuit as per this diagram. So we connect first the circuit as per this diagram. Also the same diagram using the boxes is shown over here. So kindly follow that. Now we have connected the entire field F1, F2, F5, F6, as we can see here, F1, F2, F5, F6, and now we will increase the voltage to 5 volts. And we will insert this magnetic probe inside this, and one can feel the pressure of magnetic field on hand also, and see how the magnets is aligned to the poles. Even I am rotating this, but the magnets are still aligned to the magnetic field. So this is the main magnetic field of the DC machine. Both the poles, upper pole and lower pole, is responsible for this magnetic field. For experiment number 3, intensity of magnetic field, we would require direct current machine. This is the DC machine, stator, power supply, and the electronic module, measurement module. This is the circuit as shown in the manual. We have to make the circuit diagram. We have to connect the circuit as shown in the diagram. Also, you can refer to this diagram. If you find making connection difficult, then make like this. Now, keep the meters on DC. This would require 32 volt DC supply. 32 volt DC supply is coming on group A. So here it is coming 32 volt DC supply. Now switch on the DC supply. Yes, here we can see when we switch on the DC supply, this is the effect we can see in the meters. So intensity of magnetic field induced over here affects this second pole field also. In experiment number 4, the purpose is to verify the induction law, the mutual inductance between the coil F1, F2 and F5, F6, and determine the ratio between voltage and current. So here we require 0 to 10 volt AC supply, and this AC supply will give to the D3 and D4 inputs and F1 and F2 inputs over here, and from this we can take the voltage ratios. So here D3 and D4 is there and F1, F2 is there. We will make the circuit as per the diagram given. Now here we will see the induced voltage between the coil D3, D4 and F1, F2 as shown in the figure. Okay. So from here we will provide input of 0 to 10 volt AC. 0 to 10 volt, it means we have to select D. I have selected D. Now I increase this and measure the AC voltage in both the meters. So in both the meters we will measure the AC voltage by slowly increasing. Decrease. So here we have to measure the values of AC voltage and AC current. AC voltage and AC current in both the circuits. The transformation induced voltage, the primary side for in D1 side is 5.6 and 0.039 in the field side. Current is 16.47 in the primary side and 0.857 in the secondary side. For experiment number 5, it will show the interpole effect. To determine the axis shift of the main poles due to the effect of interpole field, we would require direct current stator, magnetic probe, power supply and measurement unit. And we have to make the circuit as shown in the diagram. Also, if you find it difficult, then one can refer to this diagram also. So first we make the connection of it. Here we have made connections as per the figure for experiment number 5. Now, as we know, here both two supplies are there, 32 volt DC and 0 to 8 volt DC. So here we have used two supplies, 32 volt DC from here and 8 volt DC from here. Okay, now we apply 32 volt DC to the interpoles. And we can see that magnetic bar is aligned to the magnetic field. Now we increase the interpole voltage and we can see that the magnetic axis is rotating. Now decrease it again. This shows that due to the effect of interpoles, the magnetic axis of the poles shifts to different direction. Again increase the interpole supply. See, the magnetic axis is shifting. So this is called interpole effect. Next experiment, no load magnetic neutral axis. It is to set the brushes in corresponding of the no load magnetic neutral axis. For that we have to use direct current machine, power supply, measurement module, and this would be the circuit which we have to make for the particular experiment. Now we connect the patch cords for this experimental setup. We have made connections according to this experimental diagram. Now here we have to use 32 volt DC supply. So for 32 volt DC supply, go to A, start the DC supply. See the voltage over here, DC voltage is 37 volts, current is 0.9, and in the armature side the voltage of DC is 0.01. Now if I move this armature, we can see there is a increase in voltage.